Let's talk about chemical reactions. What's the first thing that comes to mind when you hear the term chemical reaction? Fire, smoke, explosion? Well, if you thought of any of those three ideas, you are definitely on the right track. A chemical reaction could result in either action or sometimes all three. The question that we need to answer is what caused the smoke, fire, or explosion in the first place? Let's figure it out. We will be using quite a few important terms, so let's take a minute to sort them out. The first term is atom. Atoms are the building blocks of matter. Almost everything around us is made up of atoms. As long as a substance contains atoms, we can consider it to be matter. Matter is anything that has mass and takes up space. Just about everything we see is matter. Matter constantly undergoes changes. Some of those changes are only physical changes. Some of those changes are chemical changes. Physical changes only make the appearance of a substance look different and are often reversible. Chemical changes affect the atoms of a substance. When the atoms are rearranged, the original substance has become something new. Let's take a look. Cooking an egg involves both chemical and physical changes. The chemical reaction, which causes the chemical change, changes the way the egg looks and feels once it's cooked. Anytime we cook food, a chemical reaction has taken place, which leads to a chemical change in that food substance. During a chemical reaction, the atoms in a substance are rearranged and that substance is no longer the same. It has been transformed into a completely different substance. Back to the fire, smoke, and explosions. If chemical reactions take place constantly all around us every day, how can we tell when they've occurred? Here are common clues to let us know that a chemical reaction is actually taking place. You may notice a change in color, change in smell, creation of a gas or air bubbles, heat, light, and formation of a solid known as a precipitate. Let's put that knowledge into action. We will conduct a brief experiment using some items that may be commonly found around the house. Let's get started with our experiment. Once you've collected your materials, be sure you ask a parent to help you before you conduct this experiment at home. Step 1. Use a funnel to pour 2 to 4 teaspoons of baking soda inside of your balloon. If you don't have a funnel, one can be made very quickly using scissors and a piece of paper. Cut your paper into a circle and fold the left side over the right side of your circle. Be sure that you leave space open in the bottom for the baking soda to fall into the balloon. Step 2, pour about an inch of white vinegar into your empty water bottle. The more vinegar, the bigger your reaction. Step 3, place the bottom of the balloon over the top of your water bottle. Be sure to hold on to the baking soda until you're ready to release it into the vinegar. Once the balloon is secure, allow the baking soda to fall into the water bottle. Finally, observe what happens to your balloon.
Here's a quick recap. Gather your materials, measure your baking soda, spoon the baking soda into your balloon using a funnel. Measure your vinegar, pour the vinegar into the water bottle. Place the balloon over the top of your water bottle and allow the vinegar and baking soda to mix. Observe what takes place. Be sure to write down your observations, and that will help you understand the information that was covered in today's STEM lesson. What do you see happening? Why do you think the things that you see are actually happening? Let's take a closer look as you look at the video recapping our experience. As the baking soda and vinegar mix together inside of the water bottle, what did you notice happened to the balloon? You should have noticed that the balloon instantly started to inflate as those two substances mixed. The baking soda and the vinegar were the reactants in our chemical reaction. The product was the gas that caused the balloon to inflate. What evidence of a chemical reaction did you observe when those two reactants mixed together? Take a second and figure it out. The next question will require a bit of critical thinking. When the vinegar and baking soda mixed, we were able to tell that the reaction started because the balloon instantly inflated. However, how could we tell when the reaction is completed? Watch the video and see if you can figure it out. Now that we've finished our lab experiment, what do we do with the information gathered? You guessed it, we share it. We share it using a lab write-up. Generally, all lab reports, or lab write-ups as they may be called, provide a summary of the lab experiment that you performed. It begins with a brief explanation of the problem you are trying to solve, how you believe you can solve the problem, and a list of the materials that you will use to do so. Any well-prepared scientist should be able to duplicate your lab experiment based off of your lab report. Today's lab was to solve the following problem. Would a chemical reaction take place between baking soda and vinegar? Your hypothesis would indicate whether or not you believed a chemical reaction would in fact take place between these two reactants. Remember, your hypothesis is always developed before you start your lab. Your materials would include all of the items necessary to conduct today's lab. Your procedure would be a list of the numbered steps we use to conduct the lab. Your observations would include anything you saw, heard, smelled, or felt while the lab was taking place. Finally, your conclusion should recap all of the topics covered in today's lesson as well as what you observed in your lab today. It should restate your problem, indicate your hypothesis, and tell if your hypothesis was supported or disproved by today's lab activity. What did you think? Did you see those results as the lab took place? Be sure to recap some of the terms that you learned in today's lesson: atom, matter, physical change, chemical change, and chemical reaction. Remember, in a chemical reaction, the atoms of a substance are rearranged and that substance is no longer the same. What did you see in today's lab? Take a second, write it down, think about it, write some more, and share your results. Good luck.